MathBlast 2, I can generate and analyze patterns. Create a pattern that starts with 2 and multiplies each number by 2. Stop when you have 5 numbers. I'm going to note 5 spaces here for my 5 numbers in the pattern. I know that the pattern starts with 2 and multiplies each number by 2. So 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, and 16 times 2 is 32. John saves a penny each day. The first day he saves 2 pennies. Each day he saves 3 more pennies than the day before. How many pennies does he save on day 4? So I'm going to note 4 spaces here for the 4 days. This would be day 4. And I know that John saves 2 pennies on the first day and 3 more pennies than the day before each time. So we're going to add 3. 2 plus 3 is 5. 5 plus 3 is 8. And 8 plus 3 is 11. So John saves 11 pennies on day 4. I can write numbers in standard, unit, and expanded form. I'm given a number in standard form, 23,498. In unit form, I'm going to represent different units that build that number. So I can say I have 2 10,000s, 3 thousands, 4 hundreds, 9 tens, and 8 ones. Now that's not the only way I could build the unit form. I might say there's 23 thousands, 49 tens, and 8 ones. Another way I could build that number might be 234 hundreds and 98 ones. There are many different unit forms I could use to build that number. Expanded form, I'm going to tell the value of each digit in the number. So I have 20,000 plus 3,000 plus 400 plus 90 plus 8. In the second row, my unit form is 9 hundreds, 2 tens, 4 ones. So in standard form, I'm going to put a 9 in the hundreds, a 2 in the tens, and a 4 in the ones, making 924. In expanded form, again, I'll tell the value of each digit. So 900 plus 20 plus 4. In the last row, I'm given the expanded form, the value of each digit in the number. 40,000 plus 2,000 plus 200 plus 5. So in standard form, I'm going to put 4 in my 10,000s, 2 in my thousands, 2 in my hundreds. There are no tens and there are 5 ones. So 42,205. In unit form, I'm going to write 42 thousands, 2 hundreds, 5 ones. And again, there are many other ways I could represent that number in unit form as well. I can add and subtract multi-digit whole numbers. Find the sum of 427,183 and 294,157. The key word here is sum. A sum is the answer to an addition problem, so we're going to be adding the two numbers. And it's important when I'm adding to make sure that I line up my place values here so that I can add like units. I'm going to add my ones. I get 10 ones, so I'll bundle those 10 ones and make a 10. In my tens place, I have 14 tens. I'll leave 4 of those, bundle 10 of those tens, and make a 100. I have 3 hundreds. In the thousands, I have 11 thousands. We'll leave 1,000 there, bundle 10 of the thousands, and turn it into a 10,000. In the 10,000s place, I have 12 10,000s. I'm going to leave 2 of them, bundle 10, and make them into 100,000. And in the 100,000s place, I have 700,000s. So I have 721,340. Find the difference in 615,378 and 112,492. Now the key here is difference. Difference is the answer to a subtraction problem. So I'm going to be subtracting my numbers here. And again, I want to make sure that I'm subtracting like units. So I'm going to line up my place values so that now I can subtract my ones from ones, tens from tens, hundreds from hundreds, and so on. Starting with the smallest place value, which is the ones place here, I'm going to subtract 8 ones minus 2 ones. 8 ones minus 2 ones is 6 ones. I have 7 tens minus 9 tens. So I need to go over and get some from my hundreds column. I'm going to take one of these hundreds, leaving 2, and the 100 I get, I'm going to unbundle and let 10 tens fall out with the 7 that's already there. And that's why that becomes 17. 17 tens minus 9 tens leaves me with 8 tens. 2 hundreds minus 4 hundreds, I need to go over to my thousands place, get one of these thousands, that's going to leave me 4 thousands, and I'm going to take the 1,000, unbundle it into 10 hundreds with the 2 that's already there, and that's why that becomes 12 in the hundreds place. 12 minus 4 is 8. There are 8 hundreds left there. In my thousands, I have 4 minus 2. In my 10,000s, 1 minus 1 is 0. And in my 100,000s, 6 minus 1 is 5. So the difference is 502,886 on the back side. I can determine perimeter and area of a rectangle. Determine the perimeter and area of the rectangle below. The key word in perimeter here is rim. I want to find the distance around the figure there. I'm going to go all the way around the rim. So I know that in a rectangle, opposite sides are equal. If this side measures 5 centimeters, so does this side. And if this side measures 2 centimeters, well, so does this side. And now I can make my way around the rim of the figure. 5 centimeters plus 2 centimeters plus 5 centimeters plus 2 centimeters equals a total of 14 centimeters. For the area, I'm going to take the length times the width. We learned back in 3rd grade that area is the square units that cover the two-dimensional surface. So I could think of this as 2 rows and 5 columns, and I could count all the squares that create that two-dimensional surface. But we moved from that thinking in 3rd grade to knowing that that's the same thing as taking the length times the width. So I can say the area is equal to 5 centimeters times 2 centimeters, which is 10 centimeters squared. We can also write that as 10 square centimeters. Either way works. I can identify types of angles. Classify the angles as acute, obtuse, or right. A right angle, it measures exactly 90 degrees. So let's put this little box here and we'll say, hey, look, that would be a right angle measuring exactly 90 degrees. An obtuse angle measures more than 90 degrees, but less than 180 degrees. 180 would be a straight line. So we notice this one measures more than 90, but less than 180, so it is obtuse. Okay, and then next, we have our last angle over here is going to be an acute angle. It measures less than 90 degrees. That's all for today, math friends.